in the Northern Hemisphere, it's approaching midsummer. But for my Antipodean viewers, it's getting closer to the darkest and coldest part of the year. Except in Antarctica, that's not quite what's happening. There is some crazy stuff going on in the southern pole, and that's what this video is going to be about. June in Antarctica is midwinter. It's the coldest part of the year and it's the darkest part of the year. For most of the stations and bases across Antarctica, it is 24 hours of nighttime during this period of the year. And in fact, on Midwinter's Day, the 21st of June, it is tradition for those who are wintering and staying in Antarctica over the long, dark, cold winter to watch the film The Thing. And that is, of course, set in Antarctica. And I do have a small side note here, because the opening credits of The Thing say winter 1984. Fine, but it's broad daylight. What the hell? And there's also a helicopter flying. Like, I can get behind like supernatural beings, fine, whatever, I don't mind that. But the unnatural daylight settings, what's that about? Anyway, rant over. Let's get on with the video. Temperatures in Antarctica are around 20 degrees Celsius above normal at the moment. On the Antarctic Peninsula, we've seen a new winter temperature record set. Temperatures at the Esperanza station, which is an Argentine base on the Antarctic Peninsula, reached 15.4 degrees Celsius above zero. That is bonkers. That's the kind of temperature we've got today in London. And temperatures have risen above zero every single day for 3 weeks. And that's having really incredibly profound effects, because usually at this time of year, there's like 20 centimeters of snow there. It's one of the warmer parts of Antarctica, but in the winter, you still see a lot of snow. But at the moment, there's bare ground everywhere, and that is pretty wild. In fact, it's not just Esperanza either. So researchers on King George Island near Esperanza have noted that rain is falling on top of some of the glaciers there, which is causing them to melt. And if you want to watch a video about why rain on top of glaciers is bad, then watch this one that I made not so long ago. Now, the Antarctic Peninsula is warmer than the rest of the continent. It is further north, so it has warmer temperatures in general. It's also susceptible to weather systems that raise temperatures and that can melt ice temporarily, but with those, we're talking normally kind of hours or days rather than weeks. So this is really quite unusual. We often see what's called foehn winds, which are warm, dry mountain winds caused by air flowing over mountains. And these can deliver much warmer temperatures. And again, I've got a video about that. You can watch one of these up here. But those kinds of winds are very common on the peninsula, and they can cause melting, particularly on the eastern side over the ice shelves. It can also make the temperatures a bit warmer over those kinds of stations like Esperanza and on King George Island. We also see very regular atmospheric rivers, which are these kind of long bands of heat and moisture that transport loads and loads of precipitation often, and that can dump loads and loads of rain or snow, but also bring warmer temperatures because you have very cloudy conditions. It's like thick cloud that has loads of snow in it, and that necessarily adds the kind of blanketing effect to the atmosphere, which makes the surface much warmer than it would otherwise be. This combination of atmospheric rivers and foehn winds, they can often co-occur, often makes temperatures much warmer around the peninsula. And if you'd like to watch a video about atmospheric rivers, then watch this one up here. I'm able to make so many videos about these kinds of Antarctic topics because of my supporters on Patreon. They're always evidence-based, they're always rooted in the science, and they make use of what I've learned during my 15 odd years in Antarctic academic research and also my previous life in journalism. My patrons make it possible to make these videos, and I really value their opinions. In fact, I asked them whether they would like to see this video or another one first, and they told me what they prefer. So if you value these videos as much as I value my patrons, then please do consider signing up over on Patreon, and I'll put the link somewhere up here, and also down below in the description and the pinned comment. But anyway, back to the Antarctic. Climate heating is driving average temperatures up, but it's also making extreme events more likely. And I'm going to do another reference because this one tells you exactly why and how. And speaking of extreme events, in the nearby Bellingshausen Sea, which is to the west of the Antarctic Peninsula, there is an area of sea ice missing that is the size of France. Now, sea ice waxes and wanes between summer and winter. This should be the peak in terms of how much sea ice there is, more or less. It grows sixfold between summer and winter, and it doubles the area of the Antarctic continent. So it expands hugely during the winter, and we typically see a maximum August-ish. So now we should have a lot of sea ice, and it differs year to year, like where we have the most or the least, but this part is unusually low on sea ice this year, and there's just a lot of open water. If you look at this map from the NSIDC, you can see that the orange line is where the sea ice would normally extend to in any normal year, but there are quite a lot of gaps in that Bellingshausen sector, which is just to the west of the Antarctic Peninsula. And that area that's missing is 650,000 square kilometers, the size of France. It's an interesting part of the Antarctic because it's a especially warm bit of ocean, and that is actually part of why a lot of the land ice, lots of the glaciers in places like Thwaite and Pine Island are being melted. They're getting undercut by this warmer ocean below. But it's also having an effect on the sea ice, and that can impact the ocean temperatures, but it can also impact the atmospheric temperatures, it can impact things like precipitation, because if you've got more open water, more evaporation can happen, generates more clouds, generates more precipitation. It's all very connected. And in fact, this image probably shows the missing parts a little bit more clearly. You know, there's the blue colors show you where there's more ice than is usual, and the red shows you where there's less ice than usual. So off the eastern Antarctic coastline, we've also got quite a large area of red where there's less sea ice than usual. But if you look in the Bellingshausen sector, and this is the bit that like comes right up to the Antarctic Peninsula and includes the bit that I've actually been to on the Antarctic Peninsula, you can see that there is a lot less sea ice than is usual, and that goes down to more than 50% less sea ice than is ordinary. And I guess the context is important to mention here, because for a long time sea ice in the Antarctic was either stable or slightly increasing, and then in 2016 it began to decline really, really rapidly. It kind of jumped off a cliff. So we saw record lows in 2022, followed by 2023, and things have never really recovered since. I actually wrote a paper about this record in 2023 and made several videos, which you can check out over here somewhere. And this year is kind of continuing in this vein. Will Hobbs, who is a sea ice scientist at the University of Tasmania, said that it is remarkable that we are in June and there is no sea ice there. You can see in that image, the area of red goes up to the coastline. So this is really unusual. If you're standing on that coastline in winter, you'd be expecting to see the ocean frozen in front of you. And this year you just aren't. And that is pretty wild. And alarmingly, this is actually the third time in just 4 years that this has happened for this part of the Southern Ocean. And Will Hobbs again, he says, "I don't think we will see sea ice there anymore. It's done." That's pretty dramatic words from a scientist. Yeah, it's quite a lot. Now, going back to what I started with, that heat wave or that record high temperature, that sea ice loss could have made the heat wave on the Antarctic Peninsula hotter, because it's all connected. And research shows that periods of high winds that come from further north, either over the ocean or from the South American continent, those periods of high winds are connected with both low sea ice levels and the kinds of heatwave conditions that we're seeing at the moment at the northern tip of the Antarctic Peninsula that has brought those really high, record high June temperatures. The loss of sea ice affects the entire Antarctic continent. It's a fundamentally important part of the Antarctic climate, sea ice, and it has impacts. The last time we saw really low sea ice in 2022, almost all of the penguin chicks in certain colonies died. There was an entire breeding failure, and the colonies are being affected again this year. And that's because penguins depend on the sea ice for breeding, for their habitats to raise their young. It's also like a platform for them to launch into the ocean to go and feed. And also if we're seeing rainfall, those penguins, the chicks, before they get their waterproof feathers, when they just have their fluffy chick down, they can get hypothermia because the rain saturates them and they can't stay warm enough and they die. And that is also very, very sad. But from a kind of global perspective, that sea ice acts as a glue in front of glaciers and ice shelves, and it holds them back, which means that losing sea ice can reduce that kind of gluey effect. It means that ice shelves have less, it's called buttressing, but basically holding back power. That means that ice shelves like the ones in front of Thwaites, the one in front of Pine Island, are more at risk of disintegration. And that has knock-on impacts for all of us because those ice shelves hold back glaciers which contain a huge amount of ice and a huge amount of sea level rise potential. And that could start to inundate coastlines in the coming centuries. And we already know that Thwaites' ice shelf has been threatening to go for a wee while now. In typical scientist fashion, my colleagues are saying they don't have enough evidence yet to say conclusively that this sea ice trend is related to climate change, but it likely is. It's just that we don't have enough data for enough years yet to see the specific statistical trend yet. But this is exactly what we would expect from a warming climate. We do expect to see less sea ice every year as the temperatures rise. And the reason we didn't see this emerging before, like we did in the Arctic, for instance, is that there are so many competing effects in the Antarctic, and that's from the ocean, from the atmosphere, from the ice, but also just because the continent is just so big. Its sheer size makes it more complicated to see those impacts because there's different regional trends that are acting opposite to each other. And that meant that it took a while for that fingerprint of climate change to really emerge in the data because it's just so noisy, basically. Antarctica is changing before our very eyes, and that's not going to change anytime soon. And in fact, it's probably going to keep worsening. Thwaites is already losing ice 5 times faster than it was in the 1990s. And research published this year showed that it will be probably losing as much ice by the 2060s as the whole continent does today. The British Antarctic Survey, where I worked for the best part of a decade actually, has even prepared an obituary press release for the Thwaites Glacier ice shelf. And that's because ice shelves can collapse really, really quickly, and it's prudent to be prepared. The loss of that ice shelf, I should say, doesn't mean the glacier would collapse immediately, but it is the first in a chain of events that would see multiple meters of sea level rise over the coming centuries, because just like the loss of that sea ice takes away some of that glue effect, that buttressing, if you lose the ice shelf, it's even more significant because you're reducing the amount of holding back power. That means the glacier stays in place-ish. So if you have less sea ice, you have an ice shelf that completely collapses, then that glacier can flow unrestrained into the ocean, and that adds to sea levels. Now, some things are unavoidable, and there's a growing body of evidence that suggests we are probably past the point where we can stop the loss of West Antarctica's ice sheet. That's heavy stuff. And I have spoken about the need for courage in the face of this information on the channel. But our actions today can still protect Antarctica from some of the most devastating changes. Because after all, it's never too late to make things less bad. And as bad as they are, these kinds of impacts that I'm talking about from Antarctica are going to unfold over the very long term. Like, none of us are really going to be witnessing the levels of sea level rise that are in store. And sea level rise really isn't the main problem for humanity. What really matters is what happens in the short term. You know, people are already being affected by climate heating, whether that's because temperatures and humidity are rising so much that it makes working outdoors unsafe, or because rising sea levels are making insurance costs totally untenable, or because extreme events are claiming lives and property and livelihoods across the world. And climate action has direct benefits. It buys us time to adapt, and it reduces the overall risk. And that means cutting emissions, electrifying and decarbonising society, shifting our diets, restoring our relationship with nature, buying and producing less meaningless crap. All of these things that curb emissions that scientists and campaigners have been saying for decades that we know is what we need to do. But it can often feel like there's so much resistance to these things, and to really change things, we need to get together and join forces because we can't do it alone. Individual action is so much less powerful than collective action, and we can only do that with community. So find some local people, that are near you and who also care about climate and join forces with them. You can also get involved in the community we're building here on this channel by subscribing and sharing this video with others to help it grow. And if you're feeling like you can go the extra mile, then joining over on Patreon really does help as well. If you want to stick around on YouTube and learn more about polar science, then I have an entire playlist of all my polar science videos up here, and I will see you in the next one. Cheers.